Hello students, today this is the third video of atomic structure. We are starting today actually with the fourth video, but this is a third video with concerning to that of the atomic structure, and we are starting with Bohr's theory of atomic model. Bohr's theory of atomic model I have written all the notes over there at this particular junction. I'm just reading out the notes over here. See, the first point of Bohr's theory, there were lots of discrepancies in the case of what? Rutherford's atomic model, which was overcome by Bohr. Okay, Bohr says that the central part of the atom is called nucleus, and electrons revolve around in certain selected path, which is known as orbit. No problems, it is okay. Okay, and orbit is designated as KLMNOP. Okay, so these are the designation. So he says that the central part of an atom is called nucleus, and electrons revolve around in certain selected path known as orbit, and is designated as KLMNOP. Next is only those electrons are permitted to move around the orbit which has got an angular momentum of nh upon 2 pi. Okay, I will speak to you just later, just after this part over here. MVR, angular momentum, and all these things I will explain. First, you just see to it what it's written over there. Next is when an electron jumps from the lower energy level to the higher energy level, it absorbs energy. And if an electron releases energy, then it jumps from the higher energy level to the lower energy level. So all these 3 points you have to discuss according to Bohr's theory. But this is being understandable. The central part of the atom is called nucleus and electrons revolve. That's understood. Okay. So we are starting with this second and the third point, that is for the Bohr's theory. Let us see this particular thing. See this one. The Bohr's theory in the second and third part over here. Angular momentum. First, let us discuss this. This is an orbit, and this is the electron which is being moving. From here to here, the electron has moved. Momentum means what? Mass into velocity. Angular momentum is what? Mass into velocity concerning to the radius. Okay, specific radius. Okay, see this one. The electron has migrated from, this is the initial position over here, and this is the final position of the electron. It has migrated to this part over here, and this is the center part of the, center part over here. So this is the orbit, this is the center. If it is creating an angle between the two, that angle is theta, concerning to a radius over here. That is why m into v, mass into velocity, that is having a specific mass. Electron is having a specific mass. Initial position is this one. This is the final position. That's why initial position is a bold lines, and final position I am marking the dotted lines over here. So this is what? Mass into velocity is what? Momentum. Concerning to the radius is called angular momentum. Is equal to nh upon 2 pi, where n is the number of orbit. H is called a Planck's constant, and pi means 3.14. Okay. Now please see, how did you get this particular thing? That also matters. Planck's constant. Okay. So this we have to discuss it in a lot. I will give you all the values of Planck's constant and all in the next class. But today you just understand what is MVR. Mass, the electron is having a mass, perpetually moving with a velocity v, and concerning to an angle, that means angle is concerned to the radius on angle. So MVR is equal to nh upon 2 pi. How h is coming, I will tell you. Okay, and that is equal to cap. This is what called cap. MVR is equal to nh upon 2 pi. This has to be discussed a lot. Okay, so this will be done in the next class definitely, because it has got a big varieties of applications if the time permits, but time is there, so we can discuss it. Okay, so you have it like this one. So how this H comes into play? Just see. I'm just coming to this part. See, E is directly proportional to nu. What do you mean by nu? Frequency. I think you have studied about this one. V is equal to n lambda. I think you have studied. Okay, n is what? Frequency. Lambda is what? Wavelength. Okay, so V is the velocity. V is the velocity. N is the frequency. Lambda is the wavelength. We can write this as C is equal to nu lambda instead of that. C is the velocity of light. Video velocity of light. Okay. And nu is the frequency. And lambda is the wavelength. So we have taken into consideration about this way. Now see, whenever you see that the frequency is high, the energy will be also high because they are directly proportional to each other. So if you want to remove out the proportionality sign, E is equal to K nu, you can write proportionality sign identity constant. C is a must for us. But in chemistry, from now onwards, you will know that they should not have, we will not have any constant in the contention of what? K. Okay. So what is the constant? We can use a constant to be as E is equal to H nu. And that H is called. We will not apply K as a constant in chemistry. Remember, this is a very important thing. So you find it out that what? H will be equal to Planck's constant. That means you have got this as a Planck's constant over here. And the value of Planck's constant is 6.624 into 10 to the power minus 34 joules second. Joules second. Joules second. 6.624 into 10 to the power minus 34 joules second. Okay, so here it comes to what? H is coming from where? It's called Planck's constant. Only those electrons are permitted to move around the orbit. It's got an angular momentum of what? NH upon 2 pi. This is what the next point is being said. Next is what said that if an electron absorbs energy, it moves from the lower energy level to the higher energy level. मतलब energy अगर 2 joules है, it is moving. If you are imparting 8 joules, that means what? Total is electron is what? 10 joules. That means electron will jump from the lower energy level to the higher energy level. It will jump. But if an electron, this is what? This is what? Lower to higher, absorbs energy. Okay? But undoubtedly, when you have it like this one, absorbs energy. Okay? But undoubtedly, when you have it like this one, say 10 joules are there, and it comes back to the cap, it has to come back, say in 2 joules. That means it has to lose 8 joules of energy. So when it is jumping from the higher energy level to the lower energy level, it has to release energy or lose energy. Okay, this is what the 3 statement of Bohr's was countered. So next class we will discuss about energy losing as well as energy absorbing on the context of Bohr's theory, how the color is being manifested. Thank you.